Okay, so we're going to finish this topic 111 right here. So we already did this in class, and you had your quiz and everything. So flip over. We're going to start right here, but I want you to flip over to the back side first because I want you to do something for me. So there's something called Pascal's triangle, and this is how it goes. So start off with a 1. And a 1 and 3 ones in a little triangle. So what I want you to do is, take a moment, and each new row is just like an addition of the earlier rows. So you always put a 1 to start a little bit further out, and then to get this next number, I add the 2 things above it. So 1 plus 1 is 2, and then there's a 1 on the end. Okay. So then I put a 1 here, and then I start with a 1, and 1 plus 2 is 3, 2 plus 1 is 3, and then you always put an extra 1 on the edge. Okay, so I want you to do 3 more rows of this. Okay, so I'll do it and then we'll check. Okay, so you should have this. So what you were doing right here is you were creating something that is the coefficients of when you expand a binomial. So the strange thing about this is that everything's going to start with a 0. So this right here, if you have a binomial, let's say you have x plus y, that's a binomial. If you take something to the 0 power, well, if you take something to the 0 power, anything to the 0 power is 1. All right, now the second one, this is the 0 row, this is the first row. So if you take x plus y to the first power, you're going to get x plus y again. So look right here, the 2 1s right there, those are the coefficients of the terms. So the next row would be x plus y squared. So what's going to happen here is that the coefficients of the parts, this is going to produce 3 parts. It's going to have coefficients of 1, 2, and 1. So let me show you how that would go. Because this one, we can kind of work it out. So let me down here, x plus y times x plus y. So x times x is x squared. Then I get an xy, and I get another xy. So I have 2 xy's, and then on the end I have a y squared. So if you FOIL that out. So look at what that has. It's 1, 2, 1. Now, also notice this. The first term has only x's. It has the full power 2 of the x's. The middle term, the x got knocked down, and then the y started to come into play. So, but look at the powers, they're 1 each, those add up to 2. And then the last one had all y's squared, the x went away. Okay? And so the coefficients were 1, 2, 1. So I got 1x squared plus 2xy plus y squared. So we're going to do this next one, or maybe the next 2, but take a look. So I have x plus y to the 3rd, right? This is really the 4th row, but remember we started with 0. So x plus y to the 3rd. So I don't want to work this out down here. It's too much trouble. So what we can do is use this, what's called binomial expansion and Pascal's triangle, to do this. So the first term is going to have a 1 in front of it. It's also going to have x to the full power. So it's going to have 1 and then x to the 3rd. I'm not going to write the 1. Then the next term is going to have a 3. So it's going to be plus 3. Now what has to happen here is the x dies off in power. So the x to the 3rd is going to go down to x squared. And the y is going to start to appear. Because here the y had no power. Then the y is going to start to grow. It's going to be like y to the 1st. And then the next term is going to have a 3 in front of it. The x has to die down again, so it's x to the 1st, but the y is going to grow to 2. And then the last term has a 1 in front of it, and the x is gone completely, and the y is now to the 3rd power. Okay, so that if I went and did this again, if I went and did another x plus y down here, and so if I multiplied this by x plus y, that would literally be the answer. Okay, so let's do one more right here. X plus y to the 4th, so you get the hang of it, but I might run out of some space here, so let's see. All right, so I'm going to have a 1 for my first term. So it's going to be a 1, and I'm going to have x to the full power. No y's. The next part's going to have a 4. My x is going to have a power 3 because it's dying off, but the y is going to start to come into play. And then the 6, x dies off again, but y gets stronger. And then the 4, x dies away, y gets stronger. And then the last term would be 1, and it would be no x's, but y to the 4th. Okay, so that's the basic way of how Pascal's triangle helps you to do binomial expansion. And so it's going to get a little harder because this little part right here is going to change. But that's the general gist of it. All right, so now let's go back to the notes here. So on the notes, we basically did this already on the other side, but let's go ahead and do it again. So if I had x plus 3 times x plus 3, I would have x squared. I'd have a 3x and a 3x, so plus 6x and then plus 9. Now, you might be saying to yourself, like, oh, those aren't the numbers that were on the list, but this is what it was. I'll show you later, like, how that works. Okay. And then this one here, if I have basically x plus 3 again times this answer here, because that's x plus 3 squared, so x squared plus 6x plus 9. So when I work that out, I'm going to have x to the 3rd. Let's see, then I have plus 6x squared plus 9x. In the middle, plus 3x squared plus 18x plus 27. So you see how this is like taking some time, right? And then I have to fix it. X to the 3rd, let's see, plus 9x squared plus 27x plus 27. So it takes some time to do that. So what the binomial theorem does down here, and also Pascal's triangle helps you do, is it helps you do this faster. Okay, so it's not going to be so like long and drawn out. Because imagine if it was like to the 5th power or something, that would be so annoying to do. Okay, so binomial theorem goes like this. These little pieces right here are actually coming from, that's a formula for combinations, and what those numbers are going to produce, they're going to produce this, the Pascal's triangle right here. So look, this n choose 0. So, like let's look at row number 2. This is row number 2. So this first spot right here would be 2 choose 0. And if you remember back in Algebra 2 class, there was, this is a combination formula. You can write it like this, like 2 choose 0, like that. But there's a formula to it. It looks like this. Like if I'm doing 2 choose 0, what I do is I do 2 factorial on top, and then I do 2 minus 0, which is 2 again on the bottom. Okay, so that's how, I think that's how that formula goes. Well, don't worry about it. We'll do it on the calculator. I forget. It's either one or the other ways around. Just don't worry about it for now. Anyway, all right. So if you press them on your calculator or in Desmos, you can type in this 2 choose 0 right here. So on the calculator, if you press the math button and go over to probability, see it is right there, the choose combinations. So choose number 3, and I guess I got to press the 2 first. So 2 math, and then choose 0. And so this is going to come out to 1. Okay, so that is the first spot down here on your row. All right, and then the next spot would be 2 choose 1. Now 2 choose 1, if you do it on your calculator, it'll come out to 2. And then the next spot is 2 choose 2, and that comes out to 1. So this is for combinations. Like, if you had 2 things and you're choosing 1, then you have 2 choices. That's how it's working out there. That's a whole nother lesson in itself. But that's how these numbers are created. All right, so we're just going to use the triangle because we have that there. But these are going to be the coefficients of the expansion. They belong right here. Okay, and then you see your powers of your first part, and then they start to dwindle, and then all of a sudden the second part, the B, starts to come into play, and so forth. And finally, until we have no A's and all B's. All right, so I think if we get to an example, you'll kind of see what I'm talking about here. And so let's go to one of those. All right, so let's say we want to expand we want to, oh, there's that formula right there. I messed it up. There was one more thing down there. So anyway, like I was saying before, like let's say we're trying to do row number 3, 4, 5. Like this is row 5, right? Row 5, let's do this spot right here. So this would be 5, choose 0, 5, choose 1, 5, choose 2. So if I was trying to do 5, choose 2, and I was using this formula, another way to write it is 5, 2, like that. What I would do, if I was trying to work it out, I didn't want to use a triangle, I would do 5 factorial on the top. Then on the bottom, I would do 2 factorial, the number here. And then I would do 5 minus 2, which is 3 factorial. So when you work this out, 5 factorial is 5 times 4 times 3 times 2 times 1. 2 factorial is 2 times 1. 3 factorial is 3 times 2 times 1. Well, I can cancel these out, and so then get 20 over 2, and so you get 10. So it just produces that number right there. Okay? All right. So we'll be writing that in the beginning of our statement here. So if you want the 5th power, you can use this row 5. You can either know that it's these numbers if you make your triangle, or you can build them like this right here. Okay? So I'll show you both ways. So x plus 2 to the 5th. So that means that I'm going to start off, this is the 5th row, all right, or 5th power, okay, because remember 0, 1, 2, 3, 4, 5, all right. So I'm going to start off with 5, choose 0, okay. Then I'm going to take this part of the binomial, and it's going to get the full power, 5. Then I'm going to take the 2, and it gets power 0. It gets no power at all the first time. Kind of like the y had no power when we first started on the back page there. All right, so then I move everything up. Now it's going to be 5, choose 1. So 5, choose 1. Then I'm going to have the x. He's going to die back to 4, but the 2 is now going to get power 1. Now notice, these add up to 5 all the time. Add up to 5. Then the next one, 5, choose 2. The x is going to die down to 3rd power, but the 2 is going to grow to the 2nd power. All right, and then let's see, 5, choose 3. The x is going to die down to 2, but the 2 is going to grow to 3. Adds up to 5. Then I'm going to have 5, choose 4. The x is going to grow to 3, but the 2 is going to go up to, the x is going to die down to 1. The 2 is going to grow to a 4. So let me fix that. Let's see. All right, and then the last part, I'm going to have 5, choose 5, and my x is going to be gone completely, but then my 2 is going to get a 5th power. All right, so now we know the answers to this. You could use your calculator or Desmos to figure out this answer, but look, it's also these numbers right here, so I'm just going to use those. So this is going to be a 1. It's going to be x to the 5th and 2 to the 0. So 2 to the 0 is 1, so it's going to be 1x to the 5th. So there we go. That's the first term. Plus, then I'm going to have 5, choose 1, which is 5. So I got 5 times x to the 4th times 2. All right. So let's keep a track of what we're doing here. So this is going to be x to the 5th plus 10x to the 4th. All right, plus, now I'm going to have 5, choose 2, which is 10, up on my list right here. So 10 x to the 3rd times 4. So that's going to be 40x to the 3rd. All right, plus, now I'm going to have 5, choose 3, which is 10 again. So 10x squared times 2 to the 3rd is 8. So that's going to be 80x squared. So this is my final answer appearing here. All right, the last part. Let's see, this guy, 5, choose 4 is 5. And it's going to be an x, and it's going to be 2 to the 4th, which is 16. So 5 times x times 16. So it's going to be 80x. And then finally, this last part, 5, choose 5 is 1. Right? X is to the 0 is 1, and then 2 to the 5th is 32. So plus 32. So plus 32. So there would be my expansion of x plus 2 to the 5th. Okay? So we're not going to have to do the whole thing all the time. So we're just going to do it one more time all the way through. And you saw how I wrote it up here. So I'm just going to save myself the trouble. This is to the fourth power, so I would use the 0, 1, 2, 3, fourth row, the 1, 4, 6, 4, 1. I'm going to use those instead of writing this 5, choose 0, 5, choose 1, and so forth. All right, so here we go. So I want 2x minus 1 to the fourth it is. So my Pascal's triangle is going to get me a 1. That's this part. Sorry, this paper not big enough. So it's going to get me a 1 right here from right here. Then my 2x is going to get a power of 4. And my negative 1 is going to get a power of 0. So the pieces of the binomial, they get their respective powers. These add up to 4. Then my next number is 4 for my Pascal's triangle. Okay. And then my 2x is going to die down to a third power, but my negative 1 is going to be a first power. All right. Then the next number is 6. My 2x is going to die down to a square, but my negative 1 will also be a square. And then the next number is a 4. My 2x is going to die down to first power, but my negative 1 will grow to a third power. See, that adds up to 4. And then the last one is a 1. My 2x will die down to nothing, or 0 power, and then my negative 1 will grow to 4 power. So now, because these numbers are kind of different, I have some stuff to figure out. Okay, so look, 2x to the fourth. It's going to be 16x to the fourth. This is going to be a 1 and a 1, so that's 16x to the fourth. Next part, I got a 4 times an 8x to the third, and there's a negative right there. So it's going to be negative 4 times 8x to the third. So that's going to be negative 32x to the third. Okay? All right, next part. I got a 6 times a 4x squared times a 1. So that's 24x squared. Next part, I got a 4 times a 2x times a negative 1. So it's negative 8x. And then lastly, this is all 1, and so I have negative 1 to the fourth, so that's going to be positive 1. So there's my final answer. And so basically it's just a lot faster than if you had to write this down 4 times and FOIL it out, basically. That's the gist of it. So then these last two problems are just going to be, we're just going to figure out parts of it. So if I want to figure out when x to the fourth is expanded, the power, I want to figure out the coefficient of x to the fourth when this gets expanded. So let me build my problem. My two pieces are x and 5, all right? And I know that over here, these numbers have to add up to 6. So if I want x to the fourth, then that has to be a 4, and then this has to be a 2, because I have to add up to 6. So I don't know if you noticed it, but what we can do here is, since this is the fourth, since this is 6 power on my binomial, I will be putting 6 choose, all right? Or you can go to the 6th row, and you can go to the 4th thing. So this is like, this will be the 6th, the 5th, the 4th. So it's going to be 15, but you can also do this. You can do 6 choose 4, or you can do 6 choose 2. It doesn't matter which one you do, because they're both going to be the same thing right here. Okay, so I usually just put the first one right there. So look, 6 choose 4, so 6 math, probability, choose 4. See, it's 15. All right, so it's going to be 15, x to the fourth, and then 25. So 15 times 25 is 375. So my term is 375 x to the fourth. So what's the coefficient of the term containing that? It is 375. Done. Okay. All right, this last little part here. What's the coefficient of x to the third? Okay, so let's build it. I have a 2x, some power, and I have a negative 3 to some power. Those powers have to add up to 8. So I want 3 of them to go here. And then I want, let's see, the other 5, I have to add up to 8, go there. So out front, I can do 8, choose, I can do either one, 3 or 5, because let me show you. 8, choose 3, so 8 math, choose 3, or 8 math, choose 5. Same answer, both 56. All right. So I got 56 times, this is going to be 8x to the third, times, let's see, negative 3 to the fifth, is negative 243. So those three things multiplied together would be in front of my x to the third. So let me see. Negative 243 times 56, gosh, times 8. Oh no. Negative 108,864. So my coefficient is negative 108,864. There we go. Okay, so that's what you gotta do, and most of the time you're gonna be doing something like this down here, not necessarily doing the whole thing. Just let me point out a little bit on the homework, just real quick. Sorry, hang out with me one more second. On your homework paper, on your homework paper, you're going to have a problem that might look like this, like number 4 looks like this. It says x squared minus 2 over x to the third. It's going to ask you to expand and simplify that. So look, you're going to be doing 3, choose 0. You're going to be taking x squared and taking it to the third power. Then negative 2 over x to the 0 power. And then you're going to be taking 3, choose 1. X squared to the second power, but negative 2 over x to the first power. So look, there'll be some like algebra to do in there, okay? And then in number 5 gives you this problem, 2x to the third plus 5 over x squared, and it has the fifth power. And it asks you for the constant term, so I want the constant. So the constant term means there's no x's, so build your problem. 2x to the third is going to have a power, 5 over x squared is going to have a power, so you have to figure out the powers right here that would eventually make these cancel out. So like look, if I split up the 5 into like a 4 and a 1, this is going to turn into x to the 12th, that's going to be x squared. They will not cancel with each other. And of course out here we're going to have 5, choose whatever. Okay, so you had to figure out like what goes here and here, because when they combine with these other pieces, they're going to cancel each other out and have no x at all, because you want the constant term. So it's just like a little puzzle to do. Okay, all right, well, that's it. So you just have 5 problems for homework, and I'll see you next time. Bye-bye.